Thank you for clicking on today's video. Today we're going to be using R to create some graphical displays for one quantitative variable. So in a previous video, I created some numeric summaries for one quantitative variable. Now we're going to be doing a second type of descriptive statistic using the graphical displays. So I'm going to start with a histogram. So if you can see on my screen, the code for that is hist, and then I'm going to do my data, which is, remember, GVSU, and then I'm going to do sleep. So remember that that $ tells our what variable in what data set. So then I'm going to use the shortcut keys, which is Control-Enter, to run that, and you can see my histogram pop up. Now here is the histogram, and I want to show you the shape of this histogram. If I were to draw a line around it, you can see it forming that symmetric, unimodal, and what we would call a bell-shaped curve. Now I'm going to create a box plot for the same data, and this is just box plot. And again, we're going to use that GVSU data, and we're going to do just for the variable sleep. And remember that the capitalization has to be exactly the same as what's in the data set. Otherwise, R won't know what you're talking about. So the shortcut key is Control-Enter, and you can see that data is the same. So we still have our hours of sleep. And here we have the box plot. It's symmetric. You can see that there are some outliers, but there's one on each end, which is what's making it symmetric. But you can see the shape of it better with that histogram. Now, to compare and contrast, I actually am going to make some additional histograms, but I'm going to change my variable to study. So here's another histogram. Now, when we look at this histogram, if we were to draw a curve around it, you can actually see that the tail is dragging to the right. So we would call this a right skewed distribution. Now I also am going to make a box plot. Now with the box plot, you can see that there are outliers towards the top portion of the data, and it is more difficult to tell the shape of it. You have to mentally envision it falling down on its side, so that the number line is going in ascending order, and then you can see that right skew. But again, and we talked about this in previous videos, because this box plot shows definitively where outliers are, it's beneficial for that. It's also beneficial to see where the median is. However, the histogram is better for doing shape, and that's why these are good complements of one another. So that's a right skewed distribution. And let's see if we can create one more histogram for, I don't know why that changed. Let's see, try to remember some of the, maybe is GPA in here? No, GPA is not in here. I'm going to quickly remind myself of what the variable names are using that names function. Let's try credits and see. See down here we have credits. So we'll see if this creates a different shape. There we go. That's the shape I was looking for. So here you can see that the drag or the skewness is happening on the left-hand side. So we would call this a left skewed distribution. And if we were to make a box plot for credits, let's see what it shows. Now this one does have some outliers on top, and remember that that's the benefit of seeing a box plot. This one also is very unique because if you notice, this top line is very, very thick, and you actually don't see a line dissecting the box plot. That means that actually Q3 and the median are at the same spot. So this is Q1, the bottom of the box. This is Q3, the top of the box, but it also happens to be the median. That means that there are just at least 25% of students are taking 15 credits. And then down here is the outliers creating that left skewed distribution. And these few up here are not pulling it to the right because there aren't enough, but here it's pulling it to the left because there are enough showing that. So that's how you create the graphical displays for one quantitative variable. We looked at histograms and boxplots, and those are in base R, which remember means that you don't have to load in a library. It's just the code already available when you start R up. So hopefully this is helpful for you to be able to do this on your own. See you in future videos.